Alright, welcome back everyone. In this part of the tutorial, we're going to start pushing the eye shader closer to its final look by creating proper scalar parameters for the iris and sclera, setting up specular, roughness, and normal maps, and then adding advanced layers like clear coat and fuzz, all with fully adjustable controls for maximum realism and flexibility. But before we move forward, the first thing I'm going to do is change the slider max value to 1 and slightly increase the iris depth parameter. Right now, it's set to 0.2, which gives us a fairly shallow depression in the iris. I'm going to push this up to 0.3, and as you can see, this immediately adds more depth to the iris region. Next, I'm going to update the control range of the iris diameter and change the slider max value from 0 to 1. This provides us with a full normalized range, enabling us to adjust the iris size smoothly. Now I'll set up the pupil scale parameter in the same way. I'm going to raise the slider min value from 0.65 to 0.72. This prevents the pupil from collapsing too much and keeps the deformation within a more realistic and stable range. Next, we will create a separate material function specifically for scaling the sclera texture. For that, we will create and open the material function and start with the texture coordinate node and subtract 0.5 from it. This recenters the UV space so that the scaling happens around the middle instead of the corner. Next, we will add a function input node and change its input type to scalar, which will become our exposed scale parameter, and invert it using 1 minus. This gives us intuitive control. Higher values mean less shrinkage and lower values mean more zoom. Then multiply this inverted value by the centered UVs. This is the actual scaling step. Everything grows or shrinks around the center point. After that, add 0.5 back to the result. This moves the UVs back into the standard 0, 1 space, so the texture stays perfectly aligned. Finally, the result is sent to the output, giving us a clean, reusable UV scaling function that we can plug into any texture in the eye shader. Back in the eye material, we will expose a parameter called Sclera scale and feed it into the scale function. The result of the function is then plugged directly into the UV input of the Sclera texture sample. After converting the Sclera texture into a parameter, we will create several artistic controls to fine-tune its appearance. First, add a Sclera brightness parameter and multiply it by the texture to control overall brightness. Next, we will introduce a Sclera contrast parameter. This value is inverted using a 1 minus node and then fed into a power node, giving us precise contrast control over the texture. To add more flexibility, we will include a Sclera tint color parameter and blend it with the texture using an overlay blend. Change its color to white. The strength of this effect is controlled using our Sclera tint intensity parameter. Finally, blend everything and feed it into a lerp node. This setup allows me to adjust the Sclera's scale, brightness, contrast, and color dynamically from the material instance. Connect this final Sclera lerp node to A of the final eye color lerp node. After finishing the Sclera setup, the next step is to do the same for the iris. So first, we will copy and paste every node that we created for the Sclera texture. Connect the iris texture to this multiply, then rename this parameter to iris brightness. After that, convert the iris texture into a parameter so we can control it directly from the material instance. Once that's done, add a contrast parameter, which will give us much finer control over the depth and sharpness of the iris pattern. Then we will introduce a tint color parameter to easily change the iris color. Then we will add a tint intensity parameter that controls how strongly that color affects the final result. Connect this final iris lerp node to B of the final eye color lerp node. This setup gives us complete artistic control over the iris, from subtle natural looks to highly stylized eye variations. Next, we will bring in the iris specular and roughness texture. Before using them, change their compression settings to grayscale and disable sRGB. After that, connect the iris UV final node that we created in the previous part of the tutorial directly into the UV's input of these textures, so the specular and roughness follow the same projection as the iris color and normal. Convert the iris specular texture into a parameter so it can be adjusted inside the material instance. Then we will create a dedicated scalar parameter for the iris specular intensity, which allows me to fine-tune how strong the highlight appears on the iris surface. Change the default value and set the slider max value to 1 for this parameter. This result is then blended with the Sclera specular parameter using a lerp node. Again, change the default value and set the slider max value to 1 for this parameter. Connect it to the A of the lerp node and then connect the final iris specular to its B. Use the final iris mask as its alpha. This gives us full control over how the specular transitions across different parts of the eye. On top of this, we will add a specular fuzz layer using a Fresnel node. The Fresnel creates that soft grazing angle highlight you see around the edge of the eye. Expose the fuzz strength through its own scalar parameter using a multiply node, so the amount of fuzz can be adjusted easily in the material instance. Finally, combine the fuzz with the main specular using an add node, giving us a physically believable highlight structure with complete artistic control. Connect the final result to the specular. Next, we will also create an albedo fuzz layer, which adds that soft organic light wrap around the edges of the eye. We will start with a Fresnel node to capture the grazing angle response, then multiply it with a scalar parameter called eye color fuzz, giving us full control over how strong this effect is. Sharpen and shape this response using a power and a constant node with 2 as its default value. Then add it into the main color contribution, so it blends naturally with the rest of the eye surface. Connect the final result to the base color. Now for the iris roughness. First, convert this texture into a parameter, naming it iris roughness map, which gives full control to swap or fine-tune the texture inside material instances. To control its intensity, multiply it by a scalar parameter called iris roughness strength, allowing us to precisely dial how sharp or soft the iris reflections should appear. Change the default value and set the slider max value to 1 for this parameter. Finally, blend this iris roughness with the Sclera roughness using a lerp node. Again, change the default value and set the slider max value to 1 for this parameter. Use the final iris mask as its alpha, which gives the eye a clean and physically correct transition between both regions. Connect the final result to the roughness. Now, to make the eye surface feel more realistic and physically correct, the first thing we will do is change the material shading model from default lit to clear coat. This shading model gives us an additional specular layer on top of the base surface, which is perfect for simulating the thin, glossy film of moisture on the eye. After switching to the clear coat model, Unreal automatically exposes 2 new inputs in the material, clear coat and clear coat roughness. These control the strength and smoothness of that top reflective layer. To control these values properly, create 2 scalar parameters. The first one is named clear coat, and this controls how intense the outer reflective layer is. Change its value to 0.5. The second parameter is clear coat roughness, which controls how sharp or blurry the reflection appears. Change its value to 0.05. Now, before going any further, there's one very important project setting we need to enable for this to work properly. Go to Edit, Project Settings, then in the search bar type Clear, and under Engine Rendering, in Materials, enable Clear Coat, enable Second Normal. This option allows Unreal Engine to correctly handle the second normal layer that the clear coat model uses internally, which is crucial for getting physically correct reflections on curved surfaces like the eye. After enabling this option, restart Unreal Engine so the change takes effect. Once the engine reloads, the clear coat system is now fully active. Now, let's set up the iris normal properly. First, bring in the iris normal and the second normal map. Do not change the compression and sRGB settings. Next, just like we did with the other iris textures, connect the final iris UV output directly into the UV's input of this normal map. This keeps the iris detail perfectly aligned with the custom iris projection. After that, convert this texture sample into a parameter and name it something like iris NM. Now add a scalar parameter called iris normal strength, which lets us control how strong the iris surface detail appears. This value is inverted using a 1- node and then fed into a flattened normal node. This gives us a clean, physically correct way to adjust normal intensity without breaking the shading. From there, we will separate the red and green channels using a mask RG. Next, we will mask this second normal map's red and green channels. Multiply it by a strength parameter and name it iris inverse normal. Then flip the direction by multiplying by -1, which gives us clean inverted normal response. Next, add both the iris normal and the inverted iris normal together. This gives us more control over the depth and contrast of the iris surface, especially around the grooves and radial details. Since a normal vector must be reconstructed properly, we will use an append node to rebuild the final normal by combining the added RG values with the B channel from the second normal. This ensures the z-axis remains valid and the normal doesn't collapse or break under lighting. Again, after flipping the RG channels, reconstruct the normal using an append node. For this, plug the flipped RG into the first input and reuse the B channel from the second normal map. Keeping the original B channel is important because it preserves the correct z-axis depth and prevents lighting artifacts. Once the normal is reconstructed, normalize it to make sure the vector length stays correct. Finally, transform this normal from tangent space to world space and send it to the tangent output. This ensures the iris normal blends correctly, responds properly to lighting, and works accurately with clear coat shading. After that, the combined iris normal results are normalized. Then, use a lerp node to blend this result with a constant blue normal vector using the final iris mask as the alpha. This ensures the effect stays perfectly confined to the iris region and blends cleanly into the surrounding area. Now for the sclera. We will add the sclera normal and a sclera noise normal map, which helps break up the surface and adds subtle micro detail, which makes the sclera feel more organic and less flat. Then connect the sclera scale material function to the sclera normal UV input, so the texture correctly adapts to different eye sizes. Next, to control the secondary sclera noise normal map, we will use a UV scale parameter and connect it with a texture coordinate using a multiply node. Connect it to the sclera noise normal UV input. To control the sclera normal density, we will be using a scalar parameter called Sclera normal strength, which feeds into a 1- and a flattened normal node. This allows us to fine-tune how strong the surface detail appears, without breaking the normal direction. Again, just like before, this noise normal goes through its own 1- and a flattened normal node with a separate strength control parameter called Sclera noise normal strength. After that, combine both the sclera normal and the sclera noise normal using an add node, and then normalize the result. This ensures the final normal stays physically correct and avoids shading artifacts. Just like with the iris, we will use another lerp node to blend this result with a constant blue normal vector. And in its alpha again, plug in the same final iris mask. Convert both sclera normal maps to parameters, which gives full control to swap or fine-tune the texture inside material instances. Now that both the iris normal system and the sclera normal system are complete, the final step is to combine them correctly for physically accurate shading. Take the final output of the sclera normal and connect it to the additional normal input of a blend angle corrected normals node. Then take the final output of the iris normal and plug it into the base normal input of the same node. Once the normals are blended, send the result directly to the material's clear coat bottom normal input. This allows the cornea's clear coat layer to sit physically on top of the eye surface, while still respecting all of the fine iris and sclera details underneath, giving us correct highlights, refraction behavior, and realistic depth inside the eye. Let's check the material instance. Alright, so this is it for this part of the tutorial. In the next part, I'll show you how to create the limbus of the eye and add full control over it. Then we'll use different masks to change the iris color, add a fake light detail directly on the iris texture, and also set up a Sclera veins mask. And finally, we'll add a cube map to the material and complete the full eye shader. If this helped you, make sure to like and subscribe, and I'll see you in the next part.